All right. So, uh, hello, everyone. My name is Phil Johnson, and we are Posture Watcher. So, to start, the problem that we are trying to solve here today is bad posture. Now, since the pandemic began, people have been working from home a lot more, and usually that involves sitting at a computer for long hours. And that can cause a lot of health issues, as you can see here on the right. So, poor posture will worsen those symptoms severely, especially over time. So, our solution is the Posture Watcher. Now, it is a smart chair that has an array of sensors that use machine learning in order to give feedback to the user for their sitting habits or if they've been sitting too long. And we also have a companion app where data is tracked and stored, and you're also able to change a variety of user settings, such as the time for how long before you've been seated for too long, the frequency of the notifications, and power saving, or how long till it enters power saving mode. So to talk about our system architecture, here is Gerald.
Hello. So this is the deployment diagram for our system architecture. It starts with the chair, which has 4 sensors, which will determine how much weight the user is putting on each area of the chair. And then these values are going to be sent to an analog to digital converter, which is communicating with the Raspberry Pi through an SPI leader follower communication configuration. So on the Raspberry Pi, is a computer which we are running a posture detection algorithm, which was calling Google Cloud Services machine learning trained algorithm to classify the posture into 5 categories, such as sitting upright, leaning left, and there are others, which we will explain later. The Raspberry Pi also can generate alerts, which will notify the user through vibration, and we can also send data to the phone app, which will send them their seating habits over time, such as which posture they are sitting with and which way their posture is bad or how long they've been sitting, information like this. It can also change some settings, such as how often they're notified in the app.
So our design went through a couple different iterations, and to start, we were initially going to use strain gauges to build a load cell of sorts for detecting the user's weight, and that didn't pan out very well for a variety of reasons. So we moved on to force sensitive resistors, which start out as an open circuit, and then as you apply more pressure to them, get down onto about a kilo ohm of resistance. So we used 5 of those on our prototype here, and they were kind of small, and you can see the breadboard in the background with all the wires plugged in and everything. And now we moved on to our final product, which is a full chair, as you can see here, with 8 sensors on the front that are a fair bit bigger than the first ones. So for the actual design, as I said, we have 8 resistors. Those are all feeding into the ADC. We have the vibration motors also powered off of our Raspberry Pi so that everything's running off of a singular power source. And it all runs off of a USB-C power bank, which can power the system for about 16 hours or 2 full work days, which was one of our goals. And also everything runs back to the PCB on the back where the Pi is. Now, this is a overview of the PCB. We designed the system to work with adults between 5'2" and 6'2", weighing between 120 to 240. The FSR values, the FSRs, which you can see here, can be tuned with the secondary resistor values, which are down here along the bottom. And on the right here is the vibration motor circuit, which both of the vibration motors, whenever we turn on the gates to the transistors here turn on to alert the user. So moving on to software, here's Gerald again.
I wrote the majority of the software that's running on the Raspberry Pi. This is including reading the sensor values, detecting if a user is seated or not at the time, generating alerts, the power save settings. We will shut down the system if nobody's sitting in it for a certain amount of time. We can also write the data for the machine learning model and sending data to the app. It also will run a Bluetooth connection to the app and the main program on startup. As soon as we power the system, in our demos, we will connect it to a TV, but that isn't necessary. And then also enabling the vibration mode in software. Then I did a lot of the work with the interfacing, again, mentioned the SPI connection to the chair, also the Bluetooth connection to the app, and the assisting with the Wi-Fi connection to the Google Cloud services for the machine learning algorithm.
Hi, my turn. So now that we talked about how the chair is set up and how to gather sensor data and like how it sees how these sitting, how does it tell, are they sitting forward, are they sitting good, are they sitting bad? The answer, machine learning. So for this chair, I created a model out of 6,758 different data points. This was gathered from 8 different users, and the weights were in a range from 120 to 240. So that's what we are saying the chair can accurately predict people's weights in. However, that can be changed in the future if we decide to gather data from a more diverse set of users. This data was collected with the users sitting in various common posture positions, so we could learn to identify those positions. Training the model gave us some impressive results. However, we found that in actuality, the chair is, while still incredibly accurate, a little less than this, but still perfectly fine to operate. We then never deployed a model. And one of the things we found interesting was going back from one of our earlier models on one of the earlier iterations of the chair compared to the final one, we found that the feature weights, that is how important each sensor's data was a lot more evenly distributed. That kind of meant that each sensor was more pulling its even weight as opposed to the original model, when the original sensors were a lot more skewed and some were a lot more helpful than others. A large part of this is due to the sensor type we initially used, or we ended up using. We found that the larger sensors offered more surface area and were able to more consistently collect good data. So now we have a little demonstration video for you. So this is we're going to take a quick tour of the chair. Here you can see the 8 FSRs, or 4 sensor resistors, as well as 2 vibration motors placed on the arms of the chair. And moving on to the back, you can see our enclosures. The one on the right holds the power bank, and the one on the left holds the PCB. And you can see the HDMI feeding out to the television. And now we're going to bring in a test subject. So the interesting thing is the HDMI cable is currently the only wire leaving the chair, and that is completely optional. We only put that in for display purposes. Now, as you can see me sitting, before I lean forward, you can see that the FSRs are each inputting their value, and it's currently classifying me as, rewind the video before I move real quick, you can see it's classifying me as sitting upright. However, as I lean forward, the chair will detect that. And in the next classification, it says that I'm sitting too far forward. Please lean back. So then I do that. And then maybe I sit a little bit too far back because I know I want to take a nap. I'm getting comfortable. And the new classification is now that I'm sitting too far back. If you notice under it, we also are given a confidence interval. So some of the more egregious positions it'll be a lot more confident on, whereas maybe some slight tilts would be a little less certain of. This can be used in our class. This can be used to alert users more accurately, or so do a few more. Yeah, sorry about that. So a few more positions. It can also detect left and right, but yep. But this chair can detect 5 major positions: forward, backwards, left, right, and of course, sitting correctly. So for the afternoon. Yep. We're gonna go the other way. All right, that's so as far as the app goes, we're gonna skip this slide in the interest of time, if we can do that. There we go. So all right. So this is kind of a demo of it working. So currently the defaults are I believe every 3 seconds, it's going to say, yeah, that the person sitting in the chair has been sitting too long. So this is every 3 seconds, it keeps printing that out. And now, yeah. And so with the data we gathered from that, it prints out the instances of
sitting correctly, sitting not correctly. Let me just go back to that. So you can see here that big green bar is the instances of sitting correctly, and then the yellow is going to be, I believe that is up, sitting too far forward, orange is sitting too far back, blue is sitting too far left, and red is sitting too far right. And then this is a demo of changing the settings. So currently the threshold is 9. Posture threshold is 9, which means that if you have bad posture for 9 consecutive seconds, it will tell you. And then we made the sitting threshold 12. So if you're sitting for 12 consecutive seconds, it'll say you're sitting too long. So currently, after 12 seconds, you should see, yep, so seated too long, please stand up. So that's 12 seconds. And now if we change that, so we're going to change that to just every second. So 1 second of bad posture, it'll let you know. And then we're going to do 3 for the oversitting threshold. So that means if you're sitting for 3 consecutive seconds, that considers it too long. And then,
Next video.
yeah. Oh,
Is that the last one?
yeah, I don't know. So I don't know if we have that, but basically every 3 seconds it will print out that you're sitting too long. And so you can change the settings in the app.
All right, so here's a picture of all of us sitting in the chair, and along with all of our roles throughout the project. And here's a couple special thank yous to some people who are involved, which includes all our data training volunteers and all the professors that helped us out. And so now we're going to open it up to questions.
Just curious, you had a picture of one of your group members sitting cross-legged in the chair. How would that be detected by your app?
Sean?
I think I've found that typically it will classify you as leaning left or right, depending on which chair is up. That's because one of the force sensitive resistors on the base of the chair will be obviously receiving no input because you're not putting weight on it.
We also have it here for live demo as well.
It says he was reclining too far back from the scene. Like, are you like sitting up like that, or?
Okay, that's.
Not sure if you can see the screen, but
Difficult to hear your number there farther away from the camera.
Yeah.
Yeah, I don't think they're able to. You guys aren't able to see the project. What's on the projector, are you?
Most of the time he's sitting too
That is
far.
correct. Kind of a white blob.
Yeah.
Yeah.
Attempt to sit upright. I think all of my weight is kind of on the left. So it'll say I'm leaning. It's, I think, hard to have good posture.
Yeah. It's difficult to sit like that.
Another question I have is, what sort of feedback does the app provide other than text pronouns?
Evan, can you?
Yeah, so the app provides, and we kind of ran low on time, so we didn't get to go into it too much. But there's a line graph of over time your good posture printouts versus your bad posture printouts. So it'll take the instances that it found that you were sitting well, and it'll compare that to the instances it found you were sitting not well. And then the bar graph is it'll print out, or it has all 5 types of sitting. So like left, right, forward, backward, and then good posture. And it'll take, it takes all of those and kind of shows you from the past week how you've been doing, if you've been, sitting left for too long, sitting right for too long. And it'll kind of, the idea was to make the user aware of their shortcomings as far as posture goes.
Right, but it doesn't have any like audio or haptic feedback.
The original plan was to create notifications that had to be phased out due to a couple different reasons involving the Bluetooth connection. But currently what it does, the chair does vibrate.
Yeah, the actual chair has a system that vibrates on it. So like when the time for alerts is generated, you can tell, like you'll hear the vibration on the thing.
So on that screen, whenever you saw like vibrating, sitting too long, that the chair was actually vibrating in those moments.
So does each individual sensor have a like vibration to tell you, oh, lean more to the right, lean more to the left? Or is it just one central haptic feedback mechanism?
So currently there are two vibration motors on the chair, one on each of the arm stands. So they will vibrate in unison, and they won't be able to tell you which way you are sitting correctly, but we trust the users. If they are told that they are sitting incorrectly, they can usually identify the problem and adjust themselves. This is mainly just to make sure they are not sitting in an incorrect position for an extended period of time.
Right. And then when you get up out of the chair, it stops recording, right?
Yeah.
Yes.
Okay, because I imagine somebody with a standing desk could say, stand for an hour, sit for an hour. But if the chair is in a laid back position or something, then it won't be complaining at you when there's no weight on it, correct?
Well,
No.
no.
Yeah, and that was one of the settings in the app was how long until it like re-enters into the power saving.
Mhm.
Okay, thank you for your presentation.
Yeah. Any other questions? All right, if nothing else.
So one quick question, actually.
Oh, yeah.
Yes.
So why did you choose this as your project?
Let's see. So there was, I think, what, like 14 different projects for us to choose from.
About.
And Gerald actually had the idea, or was the submitter of this one. And personally, I really like working with hardware like this. Like I'm always a big person for choosing or for liking to work with gadgets and stuff like that. And I thought it was like a really cool thing that especially seems kind of relevant today. So that was something I wanted to work on. I don't know if anybody else has any good input.
I'll just say, I was just thinking of it like what could we do that would be a decent project that incorporates some hardware, some software. It's like a relevant problem for a lot of people. That's like where I came up with it. And these guys and myself made it happen this semester.
For me, it seemed like a good mix of allowing you to work with embedded software and machine learning. I like that it actually has a real problem. Like bad posture is a thing, and people are definitely sitting a lot more now that COVID happened. Now that everyone's doing Zoom calls and remote learning, remote work. So this is something that will actually hopefully help people. Like this is a useful project, and I don't know, it's given me a chance to do things I learned about and wanted to actually create a project with. So that's why I chose it.
And I was kind of drawn to it because personally my posture is terrible, and I've always wanted a solution like this. And to just be reminded when your posture is bad is a useful thing for me. So that's why I kind of wanted to make it happen.
We're gonna run through the presentation again.
Well, just as a fun question, what do you recommend as your preferred time slots for sitting? Like, what do you think is sitting too long for a day?
For sitting too long for one period of time. Usually it's
a couple minutes every hour.
Yeah, a couple minutes every hour is what's recommended. And however, if you were someone who gets like really stiff joints or something, and you just want to set it to like 30 minutes, you could set it to that. you're like a power user or whatever, and you want to like just not get bothered for longer periods of time, you can change it to 90 minutes, 2 hours. But yeah, getting up and walking around for a couple minutes every hour is what we found was the general consensus.
Another question. How do you plan to sell this? Do you plan to sell the sensors separately or in a seat cover to put on the chair, or are you going to sell individual chairs? Hypothetically, if you were to sell this in the ideal scenario.
Well, right now our current system is well the machine learning model is trained for this particular chair. The system itself can be easily removed and put on another chair where more data can be collected and a new model trained. So in theory, this could be basically implemented on the pre-existing chairs everywhere, whether or not they're your favorite office chair you have at home or a school desk where they can be trained specifically for students in that desk so they could have entire classrooms be monitored for posture. It really can be adapted to any pre-existing chair with a little bit of work.
Okay, thank you very much.
Thank you.
Thank you for your questions.
All right. Does anybody have anything else? I know at some point we are supposed to present for judges, I believe, but I'm not entirely sure if they're here right now. So I'm going to stop the recording.